In this problem, we are going to apply exponential units. Our example states converts 5 cubic feet to cubic centimeters. When we are working with exponential units, we need to recognize that anything that we apply an exponent to, we must also apply to the equivalences, because that is going to ensure that you are doing the proper calculations. So let's recognize the relationships that we can find between feet and centimeters first. Then we can apply the exponents. From the table that you were given, you would have this provided to you, or I will provide to you within the problem, some format. You will have access to equivalences. Use the equivalences that are given, okay? So I know anybody can easily type into Google or whatever to say how many feet are in a centimeter or vice versa, but I want you to practice with what is given to you here so that you recognize how we can relate units to each other and apply it into multiple steps, okay? So in our list here, we are given that 1 meter is equal to 3.28 feet. We are also given, what else are we given? We are also given, how many steps will we do in this one? I have everything here. 1 minute. Okay. So we are also, of course, we are not given, but we know the relationship between centimeters, which is what we have here, and meters, okay? So if we have the equivalence, 1 meter is equal to 3.28 feet. That is going to enable us to change feet into meters. But recognize our units here are feet cubed. So whatever exponent that we use in the units must be applied to the equivalence. So we're going to multiply this by cube, or we're going to cube it, and we're going to also cube this. So when I put this in parentheses, that means that the cube is going to apply to the 3.28 and the foot. So this will then be 3.28 cubed feet cubed. Okay, so 1 meter cubed is equal to 3.28 cubed cubic feet. Okay, so that is our first equivalence that we will use to begin our conversion to cubic centimeters. Okay, so meters cubed. What do we know about the relationship between meters and centimeters? We know that 1 meter is equal to 100 centimeters. Now we have cubic units. Therefore, we must cube our equivalence. So now what this gives us is that 1 meter cubed equals to 100 cubed centimeters cubed. Okay, so now we're going to start doing calculations with exponents. So we need to make sure that we're comfortable with this in our calculator too. Okay, so, but of course, before we do our calculation, we're going to need to set this up to cancel the units. Okay, so now what we have is 2 equivalences. So that means this is going to be a 2-step conversion. What do we start with? We always start with the given value. The given value is 5 cubic feet. 5.0 cubic feet. Remember, to make a placeholder, you can put that over 1, okay, if you like. So we're going to begin with using our equivalence here, that 1 meter cubed is equal to 3.28 cubed feet cubed, or cubic feet, same thing. So that means we need to put feet cubed on the bottom because we're changing the cubic feet. So it's going to be 3.28 cubed feet cubed, and then 1 meter cubed on the top. So that's our first step. We're going to convert now from meters cubed to centimeters cubed. So now 1 meter cubed is equal to 100 cubed centimeters cubed. So 1 meter cubed, or cubic meter, is 100 cubed times, or with the units, centimeters cubed. Okay, so we're going to cancel the cubic meters. And now, after all the units are canceled, you will recognize that what you're left with is your desired unit, cubic centimeters. So now once the units are set up and properly canceled, then you can begin your calculation. What you will notice here is that we have values in both the denominator and the numerator to multiply by the 5, or divide, multiply and divide. Okay, so let's begin here with the 5 cubic feet. So we're going to start with the 5, and we're going to divide it by 3.28 cubed. To ensure that you do this in the calculator correctly, I'm going to go through this with you step by step. It helps to use parentheses when you are working with exponents, because it ensures that your calculator will be doing each step in the proper order of operations. So if I start in my calculator, I do 5.0. Of course, you can't see this right now, but I'll tell you what I'm doing. 5.0. This value is in the denominator, so we're going to divide. Now I'm going to do the parentheses in my calculator, and I'm going to input 3.28, and then to do a cube, what I have, here, I'll show you. Let's see if the lighting here. What I have is this button here that looks like an arrow up, okay? So an arrow up means raising to the power, or an exponent. And then input 3. And then close parentheses. So this is what I have so far here. Let's see how the lighting is. It's not going to work out too well. That's okay. So what you should see is, you can't see the 5 right now, but you'll see that the parentheses, so it's 5.0 divided by parentheses 3.28, raise the power to 3, close parentheses. Once you have done that, you can either press equal or you can continue the calculation. I'm going to continue the calculation by pressing multiplication and then open parentheses, 100, caret, or the arrow up, 3, close parentheses, and then I'm going to press enter or equal. The number that I get is a fairly large number. But what we've also learned is scientific notation. Scientific notation helps us to reduce a very large number, especially when using the correct significant figures. So let's write down what the calculator gives us, but then we're going to apply our significant figure rules and scientific notation to write our answer. So what I'm seeing in the calculator right now is a lot of numbers. I'm seeing 1, 4, 1, 6, 9, 3, decimal place, 0, 2, 5, 3. Okay, so that's what I'm seeing from the calculator. But if we're applying the significant figure rules, the significant figure rules tells us that our answer can only be as accurate to 2 significant figures. So to write this value in 2 significant figures, we need to write this in scientific notation. So the numbers that we're going to use as our 2 significant values will be the first 2 numbers in our value. 1.4. That's the start of our scientific notation. Times 10 to the how many places do we move the decimal over to give us our scientific notation? What we're going to see is 1, 2, 3, 4, 5. 5 places to the left, and it's going to be a number larger than 1. So therefore, it is a positive exponent 5. And then our units. Our units are cubic centimeters.